I'm going to talk about Pydantic Monty, a project I mostly have been working on since very late last year and lots this year. Code execution is great for agents. I think that is not particularly controversial. The problem comes when you actually need to go and use it or build it. Most of the code, or all of the code execution solutions have trade-offs. So Monty is our different take. I don't claim that it will solve everyone's problem all of the time, but I think it is filling in a lacuna in the spectrum of different options that existed until now. There are some other projects going on in the same space, but nothing quite exactly the same as Monty. So inspiration for this, as I say, I don't think code mode as Cloudflare call it, or programmatic tool calling as Anthropic have called it, is controversial anymore. This is the idea that if you give an AI access to write code instead of calling tools directly, it can perform better, it can be cheaper, it can be faster, it can be more reliable, et cetera, et cetera. I think that there is lots of nuance in how you do that really well versus somewhat well, which I will touch on here, although I don't claim that we have fixed all of it. There is this continuum that I have called here impotence versus chaos. When you harness an LLM, you make a trade-off between control, the control you retain, and the capabilities you grant. At one extreme, you have tool calling. The LLM returns some JSON with a function name and some JSON data, and you can call one tool. Great, but it is somewhat impotent in many cases because you have this one very simple way of basically interacting with the outside world. The other extreme, you basically hand over control of your computer to a neural network. And the kicker is that neural network is trained by a company who made their money out of flouting all data conventions. So we may not be entirely keen to do that all of the time. My point here is there are always trade-offs. So if you look at this diagram here, and it takes some getting used to, but in terms of the continuum, we have tool calling, as I just talked about, Monty, which I'm going to get onto. Then you have the sandboxing services, which are booming right now in the middle. And then you have coding agents in terms of further along. And then you have, it doesn't really happen that much today, but at least theoretically you have full computer use. You just hand over your computer to an LLM and it can do everything. In general, you substitute capabilities and power for control, and you also increase the chance of failure, the cost of inference, the latency as you move across. Sandboxes are special in the sense that they have their own separate price associated with them. But my point is not to say that one point on this spectrum is good or bad, or that some points here are relevant and others aren't. There are going to be people building economically valuable things all over the spectrum. There weren't many things between tool calling and go and run this sandbox. And in particular, those sandboxes are problematic for people who are individual builders or people with low income, but they are also, you have this bathtub curve where you have individuals have problems with it, and then enterprises have massive problems. Because if you are a bank or a financial institution, healthcare institution, you can't just go and sign up for whatever startup is doing doing sandboxing and go. I was also speaking to a big, or getting in touch with a big car manufacturer who want to run agents inside their cars. Even if you have a small LLM running inside the car, yeah, sure, in theory you can have some VM like Docker, but it's not by any means trivial to set that up in the compute you have in a car. So in those constrained situations where you don't want to go and use an external sandbox, that's where I think Monty will be most powerful. So what is Monty? It is a minimal, secure Python interpreter written in Rust for running code written by AI agents. In particular, this is not a fork of, I made a joke earlier that this is a kind of slop fork of CPython. Then I said that's not true because it's not a fork. It is built entirely from scratch. The only kind of foundational thing we use is Astral or Rough's AST parser. Thank you very much. So they have some excellent code to go from pure Python code, the text, to a structured data object, which you can then use, and that's obviously very fast, so we use that, but from there on, the entire implementation is written from scratch. And the point is that because we're writing it from scratch, nowhere in the code base do we have an open implementation that can read a file. So we are building from scratch upwards rather than taking an existing implementation and chopping bits off until we think it might be safe. This is a kind of hello world example. We're gonna, so obviously we then take Monty, this implementation in Rust, and then we wrap it with PyO3 to give you a way of calling it from Python. What's nice is because it's purely a Rust implementation, you can actually call it similarly easily from JavaScript, and we actually have other implementations in Dart and Kotlin in PRs. Block in particular was super keen on doing it in Kotlin, and then the day after they submitted their PR, their entire engineering team got laid off. So I don't think that one's going anywhere, but other ones might. So I go and run this example. You can see it runs instantly, and in this case just does a print. But we can do much more powerful things than that. So what is it? The first point is that because we're building it from scratch, we can build it and nowhere in the code is there even compiled in the option to just simply open a file. The open implementation or the socket implementation, they just aren't there. So we don't have to reason about, are we definitely sure we've set the right compile time flags or set this correctly, set up my C groups. The code literally does not exist in the code base to just go and call open. Now, we do allow you to simulate opening files, but that is all via this system of callbacks. So we allow you to basically call a prescribed list of functions on the host. But we don't do that via the traditional system of callbacks where you pass a bunch of function pointers into Monty and it can then go and call them. Instead, we suspend execution whenever you get to one of these external function calls, and basically it's very much like tool calling. We return a function name and the parameters to that function, the arguments to that function. The host then chooses whether or not what function to call, whether or not to call it, what value to return, and then execution continues. The kicker, and I'm kind of jumping ahead here, the kicker of that suspension, of that returning from execution is that you can snapshot the entire runtime at that point if you want to, and go and put that in a database and return later. So if you have a tool call that's going to take 2 hours or 2 days, you don't need your Python process hanging around waiting for that tool to finish. You just snapshot your runtime, put it in a database, and then when that tool finishes, you resume. You could also imagine that if individual users in a SaaS application wanted to each have their own context in which their agents write code, you could be snapshotting each individual user's code as they run it. When they stop doing something, come back tomorrow, rather than having to have one VM for each of your users. The other thing, I lied. The other thing we do take completely from Astral is TY, their type checker. So because that's written in Rust, we're able to build it into the binary, so you get type checking completely built in without having to do any extra work. We can use this callback system for also allowing pseudo file system access. So we can basically do a return a like read file and what that file is called, and the host can decide how it's going to deal with that. That also means that if you want those files to live in object store somewhere, you can completely do that. You don't need to, it's just as easy as implementing normal files. Because Monty is embedded, it runs in the same process where you're running your agent. The latency of starting it is around 1 microsecond. I think in Python, you generally get to kind of 4 microseconds. But when you compare that to you calling a sandbox where you're taking around a second, we're looking at like 6 orders of magnitude of speed up. Portability, as I said before, because it's implemented in Rust, you can run it anywhere. There's no worry about which C groups do I need to be able to go and control. Does it run on Windows? Does it run embedded? If you can run Rust, you can run it. And yeah, no extra sandbox required. But there is a trade-off, and I'm going to be very blunt about this trade-off. Monty is a small subset of Python. It is not designed to, and it probably never will, be able to run your Python code. This is not a situation where you can say, I've got my application, oh, can I go and run it with Monty, which was always the hope with projects like PyPy, and honestly is the reason that there is this graveyard of other Python implementations, was that to be a alternative to CPython, you needed 99.59s of compatibility with CPython. And even then, if something went wrong, you'd be like, oh, why don't we go back to CPython? This is not trying to be an alternative to CPython. It is for a very specific use. So we have this very golden rule, which is Python is the truth. We speak nothing but the truth, but we are not claiming to speak the whole truth. In other words, if you ask what is right is what CPython does, by definition, but we are not claiming to do all of the things CPython can do. So for example, I don't think I have it in this deck, but at the moment you can't define classes. I think we will have classes. The standard library, we have to implement each module in Rust effectively, so we have like math and re for regular expression, and datetime I think is coming soon. We'll have a handful of the things that LLMs want to use regularly. We are not ever going to go and implement the full standard library. And there's a few other things like context managers that I think will come over time. Oh, and most notably of all, you can't use, by default, external libraries. So you can't install Pydantic or requests. We will have workarounds for those things. In fact, there's a PR up now to implement most of NumPy. And indeed, he's also implemented most of Pandas in that same PR, which is one of those like 10,000 plus PRs that we need to collaborate with him to work out how to get that solved. Side story, I nearly went and closed that PR and said, what the hell are you doing? And then just before I did it, someone in the team pointed out he's from a large hedge fund who we're working with closely. So lucky I didn't. But it shows the kind of people who are interested. Yeah, so coming back to this continuum, and I think I touched on this before, the conventional wisdom until now has been start on the right and basically constrain and move towards the left when you need to be secure, or when you need to lower latency, or when you need to be able to restrict what the LLM can do in the interest of saving context. We start from kind of as far left as we can, and then we add on individual bits. And the point here is we know that there are lots of things that are missing, and we can have people come along and report those bugs, and we can add them. But it's like whitelisting. You start with a restricted list, and then you add things when you need them, rather than starting with a blacklist and going and playing whack-a-mole with security issues. I'm not saying we'll never have a security issue, but I think that the foundational approach is better than the blacklist approach that is ultimately what most sandboxing is doing. I think the other thing to say is you look at these other approaches. Docker was not designed to run untrusted code. It was designed as a way of setting up a particular environment. It is itself 15 different Linux tricks in a trench coat. It is somewhat reliable, but it's not perfect. Another one that people use is PyodIde. PyOdide is an amazing project for running Python in the browser. It is a terrible way of sandboxing, both because it's slow and because it's often not that secure, because it wasn't designed for sandboxing. I'm a massive fan of PyOdide. Hood is my friend, but it's not designed for this, which is why it doesn't work. And that's true of most of the low-level technology. Monty is the first or one of the first projects where someone's come along and said, let's build something specifically for this use case. So I'm going to go into a demo. This demo has failed quite a lot of times. And so you may see another failure here, but I'll talk you through it more than running it necessarily. So ultimately, what we're doing here, we have some external functions, which is what we're going to expose to the LLM. So we give it this SQL query interface where it gets to go and query a particular SQL file. It's going to use DuckDB internally. And then we're going to have a plot function, which is going to use matplotlib and generate a plot. The point here is, obviously, inside the runtime, we don't have a plotting library. We don't have a SQL database. But by exposing these functions into the runtime, it can do arbitrary stuff on the host. And of course, the kicker is you pay microseconds of latency for calling back to the host and no complexity. Whereas if you go and set this up with a sandboxing service, being able to kind of register functions from the host within that sandbox is incredibly, incredibly complex. So yeah, we have plot, and we have the show plot function, and then we have a display table, so it can display a nice table to me that's going to go and use, I think, rich internally to display the table. What I realize I haven't got open here is the context of why I'm investigating this. So the reason that the thing I'm trying to understand is what the hell happened here. So this is the downloads of Pydantic AI. And you can see that we had a number of downloads we were quite proud of, like just shy of 1 million downloads a day. And then suddenly, over the last few days, the number of downloads has shot up. We were trying to work out why this is. But I didn't particularly want to go and spend half an hour writing SQL to investigate in BigQuery what was going on. So instead, I exported all downloads of Pydantic AI into a Parquet file from BigQuery. Then I just gave that Parquet file to the model and said, investigate, work out what's wrong. But of course, it wants to also be able to write code to do these plots that uses that data. So just doing tool calling would be either extremely slow or not work. And so, yeah, because we're going to do type checking, we need to generate the stubs for that external functions file. Some of this stuff will soon be features of Pydantic AI, so you won't have to do all of this setup. This is a kind of from the ground up implementation. We have some prompt where we tell it what it can and can't do in Python. At some point, lots of these you're not allowed to use modules will be added. We have our Pydantic AI agent, which is ultimately what's going to go and drive this. I will say, I don't know quite what they've done with Opus 4.6 and Sonnet 4.6. The models are great in general. They are woeful at this kind of REPL coding. I think they have been overtrained on some specific form of code execution, and so Opus 4.5 and Sonnet 4.5 do far better. And I think that's honestly a tricky thing to go and work out. If there are only going to be certain models that can do this, it's going to be problematic. I suspect long term they will all be able to. So we take our external functions that we're going to be able to register. We do this loop thing in Pydantic AI. Again, you won't need to do that in future. But the real point is we're not even doing tool calling. We're just telling the LLM, reply with some markdown, which includes some code box, and we will go and run that code for you, and you can basically include comments that we'll print out as we go along. And here are the functions you can call, and we're also going to insert those stubs into the context, so it has the kind of functions it has access to. And then we come down here to where we actually run the code. I realized about half an hour ago that our REPL implementation that we're using here doesn't yet have the type checking built into it. That was a mission for me, so that will get fixed. So I'm currently doing Monty twice. First, just to do the type checking. So this is all we need for type checking true and give it the stubs that it needs to enforce the types. And then we're going to use this run REPL async, which will take care of extending the runtime as running it as REPL. One of the problems we had with Monty to start with is these models are built very much assuming that they are going to be run in a REPL scenario, e.g. that everything they've done before is going to be available, and we basically had to go and implement that to make them work better. I'm running out of time, so I'm going to cut going through all of this stuff, but I'm very happy to talk about it later if anyone has any questions and run it. And like I say, this sometimes goes well, and it sometimes does a terrible job. So it's a voyage of discovery. Hopefully you can see my terminal. I'll set that off. Won't be anything to see because it'll be doing the first thinking about what to do. But we can come over here into Logfire, and we should be able to see pretty quickly what it's doing. So you can see here from the, I'm going to make this a little bit bigger, but you can see the system prompt that it got in full here. So it had the description, then it had the stubs, and then ultimately it was asked what to do. And you see it returns some SQL to describe the table, and you see it's now able to generate these plots. And again, this is happening in a scenario where now, most of us, if we did this, we would just use Claude Code and hope for the best locally, and that's fine. But if you're doing something like this in the cloud, you can't just run the Python on that machine and hope for the best. And so this is kind of, I would argue, a more powerful way of doing that. You can see here there was an exception. It got a typing error from TY that was returned to the model saying, here's the error of how you got the types wrong. And you can see it was then able to fix that, and the next time it ran, there was no error. And you can see here it's still chunking away, working out what's going on. And hopefully at some point it will get to an answer and work out why the hell someone started downloading our library. Spoiler, it's definitely not real usage. It's something weird that's going on, but it's interesting. Thank you very much. I might have time for one question. One question.
What LLMs?
Sorry?
What's your preference for LLM? What model?
I have found Anthropic models to be much better, but as I say, 4.6, both Sonnet and Opus, do some really weird things. I think they have been micro-trained on a particular code execution environment and don't work very well. So currently, both 4.5 models are best. Any other questions? Otherwise, we're at time. Thank you so much.